All right, so once again, we're going to talk about this chart and this line graph that we made from the lab. And if you remember, we just put some ice in here. We put a little bit of water. We stirred it up. We were basically right at 0 degrees Celsius, right? And then we started heating the water up. We put it on a hot plate. And it slowly melted. And then once it was a liquid, it heated up very quickly. And then when it got to the boiling point, the temperature leveled off again and it boiled, right? Okay. So I got some terms that I haven't used as much. One thing is, we were definitely, it would be very reasonable to expect that when we heated this up, you would expect to get just a steady line increase, okay, in the temperature. But that's not what happened. What happens in reality is, you hover down here around 0 for about 5 minutes for the amount of water that we had. If there's more water, it would take longer, right? Hover down here, and then once it turns to pure liquid, the temperature starts shooting up, and then after, I don't know, about 15 minutes or something, then the temperature leveled off again. So you have this definite 3-stage graph here for us. We already started out down here. So what's happening down here? Melting. All right? Melting. As we're getting hotter, this flat area of the graph represents melting. And the energy here is hidden. What I mean by hidden is, you can tell when you see the graph going up here that this water is sitting on a hot plate, right? But right here, it doesn't look like it's sitting on a hot plate. So the energy coming from the hot plate is kind of hidden from the graph. Does that make sense? And that hidden energy we refer to as latent. All right? And did y'all get that term yesterday? Some of you people at home didn't get that term. It's latent. All right? So latent energy is the hidden energy of the melting process. Okay? Because it takes energy to melt the ice, right? Now I've got a new word for you. Okay? It's a new word for melting. And this word is called, anybody know? Huh? Yeah, that's right, because we just blipped by it in the other slideshow. Fusion is in your slideshow, in your notes. Fusion is a word that means melting. And the amount of heat that you don't see on the graph here that is used to melt the ice and get it to this point where we start shooting up, the amount of energy to do this is called the heat of fusion. Okay? And the heat of fusion, right, is the amount of energy used here. And the energy coming from the hot plate is latent. It's latent, or it's hidden. You know, once we get to right here, there's pure liquid in there, because we're not wasting our energy melting something. So you can see the energy from the hot plate on the graph. Okay, so there's no latent energy here. And then when you get up here again, the graph flattens out. The energy is once again what we call hidden or latent, right? Latent energy here. So what is happening up here? It's boiling. A better word for boiling is vaporizing. All right? So there's latent energy here being used to vaporize the water. And that's why the graph isn't going up. Okay? The amount of energy it takes to boil this much water is called the heat of vaporization. Just like this is called the heat of fusion. Correct? If you look at this graph, and I know I've driven this point home several times, you can tell this is fresh water because it's melting at 0 and it's boiling at 100. So looking at your chart, you can often tell what substance the chart is about, right? This chart, since it's going up, would be called a heating curve. Okay? Now, we don't always heat things up, right? We can do the opposite. And we could cool it off. I'm going to make you another curve right here. Let's start right here. This is going to go down, and then we're going to have a flat area here. This is going to go down again here. We'll have a flat area here, and this is going to go down again here. And it could just, I don't know, it could go off the chart. Doesn't matter. First thing I would say is, hey, is this water? No, you know it's not water. How do you know it's not water? Now we're cooling it off. So what is it about the graph that shows you know it's not fresh water? Okay, well right here and right here are where the phases are changing, right? And water would have the same amount of phase changes, right? So look at this part and tell me, what part right here tells you that this isn't water? What do you think? All right, I'm going to come back to it. All right, right up here, we've got a gas. This one we start with a gas, and it's cooling off, right? And when this gas hits this flat part here, right, it's trying to turn into a liquid. What is the word for a gas turning into a liquid? Think about water vapor in the air turning into a liquid and then raining down. Condensation. So the opposite of boiling is condensation, right? So this is condensation. It's condensating at 65 degrees. Why do you know this isn't fresh water? Anybody?
Oh, because water doesn't condensate at...
Correct. If this was water, the line would be up here at 100. Does that make sense? So you know it's not water from where the lines flatten out. Look, this is condensating, right? Now, remember when we were going up, we were talking about how the graph showed that at the flat line, it was absorbing this latent energy. What do you think it's doing right here? Do you think it's absorbing energy to go from a gas to a liquid? Which one of these is the higher energy state, gas or liquid? Gas, correct. So if we're going from a gas to a liquid, can we absorb energy? No. What's the opposite of absorbing the energy? Giving it off. That's exactly right. So we're giving off the energy here. Okay? All the latent energy here on the graph isn't being absorbed by the water. The water's giving it off into its environment. Okay? Or this isn't water. The substance is giving off the latent energy here. There's still latent energy here, but it's not being absorbed. It's being given away. So the gas is going through a physical change right here. There's latent energy here being given off, and there's a phase change from a gas to a liquid called condensation, or called condensating. Right? Right? So right down here we got a pure liquid. Once we're at pure liquid, it just cools off faster because there's no phase change occurring here, right? Then once again, we have latent energy here. And is this substance going from a gas into a liquid, going from a liquid to this is going to be a solid down here? Is this substance going from a liquid to a solid, is that called melting? No, what's the opposite of melting? Freezing. So there's freezing occurring here because it's going from a liquid to a solid. And look, the freezing point of that substance is like 30 degrees. You know this ain't water. Water's not going to freeze at 30 degrees Celsius, correct? So there's latent energy here. The process is freezing. It's giving off energy. Yeah, wait a minute, Mr. Perkins. For something to be freezing, it's giving off energy? Absolutely. It has to give off the energy to be at this lower energy state, correct? So we have latent energy here and here. Instead of boiling, this is now called condensating because we're going backwards. And instead of melting here, now we're at freezing, correct? And instead of absorbing energy, it's giving off energy. And if we would have done this lab, you guys would have predicted, oh, there'll be a line straight down. But now you know, at the phase changes, there's latent energy that flattens the graph out. Does that make sense? So that's our complete review of this. And there's a little assignment in today's Google Classroom you guys can do right now on the ice lab graph.